Hello beautiful people. This time we're going to look into some technical solution how to find the proper pscale. It's not a tutorial this common way, it's rather like overview of different approaches. Maybe you find this useful. Why not? Let's pack it. This time I'm preparing a few options, and all of these are not like magic pills for you to solve every end problems you have. But I'm going to give you like a general solution with the vex, maybe with some for each, and measuring the perimeter and area of the polygon to copy that, and then the 3D object as well. So you have a general idea. Let's jump in and create a grid. This grid will represent as a flat surface. I would imagine you have a flat surface, you need to scatter points and calculate the radius of each point, so that will not visually intersect with each other. Of course, let's do that. Let's create a scatter. Let's lower the relax iteration. That will give us more of irregular shape of the points. Then let's create a circle. We want this circle to be a polygon, probably a little bit more of this subdivision, so it be more roundy and different orientation. And let's create a copy the points. To the left is geometry, to the right is points, are points. Okay, and we have that, and everything is okay, but you need to calculate a proper radius for that points. In order to do that, let's create an attribute triangle, do it over points. This is kind of iteration over all the points, and I'll give you maybe 3 options for that, and obviously they will do the same thing with different codes. More like I don't know, maybe you need to know, or maybe you want to use one over others. So in order to use first, I will use a function called pcfind, and this function will iterate over points and point clouds. And for example, as you could see, we will use this different pcopen and these functions, and pcfilter will allow you to read some values and attributes from different points and averaging that, blurring that with the given radius and the given amount of points. But this one will give you, let me find that, pcfind is here, returns a list of points closest to the point of a file. So that means that that will give me an array of points, and that the first point in this array will be the closest point to myself. So let's implement that. First, obviously, I will need to find an integer close pt, which will be this one, and I will use a pcfind function in input 1. And then I need to specify, I think, string position, then vector position, then I need a float radius. For that I will hardcore that, 0.5 for example, or let's be, and then just to show you I will use 2 points to search. And we could say for this example that could be an attribute, array attribute closed pt. And if you go to geometry spreadsheet, you could see that we have this array. But in this case, considering we're using the same input and we're using ourselves, so each point will look for the closest point, and the first one will be ourselves. So pt num is 0 and the closest one is 0. So again, if we increase that, that will give us 3 points in order of increasement. The further the points it be from the searching points, that will be the next number. And we could use 2 and have 2. And for the next thing, I would like to retrieve only the second one. We could either remove with function remove, or we could simply specify that as a, let me show you, integer pt would be like our close pt array, and I need only the second one from that array. That will give me the number from this array, the second number. I will move a little bit further, but for now I just need to explain it more closely. And the next thing, obviously, we need to find a position of that point, the closest point. That will be a vector pos close, and we could use a point function. Again, from the first input, we are searching for the position attribute, and we need this pt, which will give us a nice number of the closest point. The next thing, we need to calculate the distance between these 2 points. So we could use a function called distance. We use ourselves as a point position, and we need position close as a second argument of this function. And now we could see that if we apply this pscale and write a distance, that will give us almost everything that we need. And in this example, it's cool because you could see like where it's the second closest point this, and you could see it's perfectly aligned with this point. And maybe you need this nice ornament, but obviously we need to divide that by 2. This way you have not just the diameter, but radius, proper radius of the point. And what is cool about that no matter how you will change, it's cool because now you could see that the searching radius is not enough. For that, let's do it 2, and that will solve, for obvious reason, our thing. And again, no matter how you will change the total count of the points, or maybe you want to change iteration of relaxation, or you want to move these points, obviously you need a flat surface. And for example, if you move points, even with mountain slope, I guess we could do that. Not just a point jitter, but with a mountain slope, and we use a position. And as you could see, we don't need to change a y direction. We could change an amplitude, and that is cool already, because you could use an animation, give it a little bit of space, and as you could see, all the points are moving, and all the pscales are changing accordingly. That is cool. For the last thing for this example, and that could be applicable for the other one, I would use different method of generating the points. For example, point generator. This one considered one of the fastest one when you need a lot of points. So let's give it a try. And all these points for now in the same position. So you want a point jitter. In this case, it's cool. Yeah, let's do it bigger and not change the y position again. Even now you could change that here and see that, yeah, indeed that works. And maybe a point relax for this kind of stuff should be great, but probably we don't need a pscale. And let's do a relax in 3D space. It will take a little bit of time. So yeah, it's obviously too much for this relax iteration, but because you could see, that is cool. Let's give it like 5/5 maybe. And it's more like a flower, and it's cool. I'll just give you an idea of how that could be used. Okay, let's move further and let's move a little bit faster, and obviously everything we will do just be the same as the iteration of this logic. Let's copy this one and just rebuild it a bit. Align it. Okay, we have a grid, we have scatter, we don't need a mountain for now, and I would love to have less of the iteration. So now let's use a nearpoints function. That's why everything should be the same and the logic should be the same. But let's not use this one for the handle. And I could use a function called nearpoint. So integer pt is equal to nearpoints. And that will basically give me the same. I need a vector, I need geometry, max distance, and points of number. That will give me a list of points in the order of closest to furthest. So let's see what we have. We need first one and the second one. First one will be the selves, and again I need to change name, close pt. That will do the same. I will just check for the second point in the array, then I found the position of this point again, and that basically should be the same, which is not because I need a close pts. And as you could see, yeah, indeed that is the same. I'm not sure what you want to use over one of the another. This is like pcfind and this is nearpoints, and I will give you one more which is cool, and we will move on. Okay, let's copy that, and this time I have the scatter, I have this, but let's delete all of that and let's use a different function, which is also cool in my opinion. First I need a handle, and I will use integer handle and use a pcopen. This pcopen function is open a point cloud, and this is very cool because it has estimates and blurriness of the amount of points around the area you will specify. So I need a string p, I need a vector p, then I need a float distance. In this case, again, let's just write it here, and I need amount of points, let's say 10. Usually with this pcopen you will use pcfilter, which will give you the ability to read the attributes from the points you will specify, but we will use a little bit different function. Float dist equal to pcimportbyindxf float. It's a bit weird, but pcimportbyindxf float, and we need, so this point have different functions inside string channel name, this one, and that could give you like a straight distance to the closest point. First argument is the handle, and we have already done that. First one is this, then we need a string point dot distance, and the last one is 1. So that one should give me a distance to the closest point, and if we apply that to the pscale, again distance, that is working, and if we divided that by 2, that is again perfectly aligned with our circles. This one is a bit more of a compact, and you don't need to go inside of these arrays, just using this function pcopen pcimportbyindex, and I have point distance dot distance. It has point number, I think. Let's see what we got here. This string, this one channel name, maybe on the import. Yeah, you have point number, and point distance. The number of the point being perceived and the distance of the point being perceived from the query opened. Okay, so we have these two. Yeah, let's move on and let's do a little bit different now. And the next one is a bit different. I will leave this copy to point. I don't need this guy and I don't need this guy. In this scenario, I would imagine that you need to copy in the center of each primitives different circle. As you could see, let's change the orientation. It's not right. Again, we need to calculate some relatable pscale, and we need to place all these circles inside of this polygon. So we need a center point of this particle. And obviously this will work with the quads, so pay attention to that. You need quads or flat surface again, because we are talking about the flat surfaces. But it's cool. So considering we have different approach, we need a for each primitive. This will give us the ability to work over each and single primitive, in this case this one, and I want to calculate b box of this primitive for each primitive. So let's do a point wrangle, primitive wrangle. Let's do a vector of box is equal to get b box size from the first input. So every time it will calculate x and z direction and give me a vector of that. So now when I calculate that and I have this information, I could use another attribute wrangle and calculate the pscale considering the minimum size of this grid. So if we have different size, pscale will be fitted inside and circle will be fitted inside of this polygon. So let's do that. Min size, let's call that this way. And I need two sizes of this box. The first one, box X, will be a component of that box attribute, X, the first one. And if you go here on the geometry spreadsheet, you could see that we have X, Y, and Z, so we need a third one. Let's copy and let's call it box Z, and let's do box Z as well. So the function to calculate the minimal size of both of these would be float min size, and that will be minimum of these two float numbers. So box X and box Z. That will give me the minimal number from both of that. And to see something, yeah, let's create a pscale, an external attribute, and let's call it minimum size. And before doing that, obviously we need to have twice as small. And let's see. Let's turn this to single, and we have nothing because we are working on the points, and probably we need to go and working on the primitive. And it's not working because it's a primitive. We could use an attribute promote, but let's go ahead and create an attribute wrangling again, and that will be center point. This center point will be created based on our polygon. So let's do a primitive one, and let's create a center point. CPT is equal to add point function from 0 and based on the position of the primitive, and that will give me the point in the center of these quads. Again, that will work best with the quads, with the rectangle, but as soon as you move to the triangles, I don't think it's worked properly. We will see in that later, but yeah, let's stick with that. And consider we're in the primitive level and we need to set the pscale to the point level. So let's use a setPoint attribute function. This one is boom, boom, boom. 0 pscale points cpt, because we only need that for these numbers, and probably the value we are going to retrieve. So float pscale is equal to pscale, and now we need just to use pscale. Yep, that should do a trick. And indeed, I need to change the orientation again to the proper one. And as you could see, that is fitting properly and correctly. And the only thing you left to do is, I'm not sure, because yeah, it has all the points on the side, but we don't have a pscale for that points. And in this case, you either want to create a set point group and use this group as a target point for the copy to points, or you want to maybe delete all these primitives and these points and left only with the center point. Let's do that. And we could say something like if point number is not equal to cpt's newly created points. Let's remove a primitive, remove a prim, 0 prim num and 1 points as well. So this way we successfully deleted all the points. And what is great about this and cool about this method, that you could change all the sizes of your grids, and that will place the pscale accordingly and cool. For example, you could use a subdivide node, and this subdivide will only operate over 0 and 5 and 8 to 20, for example. As you could see, yeah, cool, only these grids. And we can subdivide it labs. This is cool as well, because it will give you some cool and nice separation. As you could see, yeah, that is cool, because now, again, you get all these different parameter, and you could use that. And all this object will be placed accordingly. Again, that could be a tube or your model or anything you need. And in this case, obviously, I need to increase the radius scale because why not? And yeah, now we have that. So let's move further and do a 3D object. So let's go ahead and create this test geometry, beloved rubber toy. I don't need the shader. Let's say I want to create again a point in the center of this of each polygons, and do basically the same and see what we got. Let's use just a bit of a different approach. Let's firstly create a normal on the point level, just to properly copy our objects, because without normal that will give us different direction. And again, circle, copy to points, and see what we got. Yeah, it's awful. Next, do a primitive split sop that will split all the primitives, I think, by one piece. And if you do exploded view, for example, that will show you what we have, something like that. As you could see, all the primitives is a separate object. It's cool. Now we could do a primitive properties that will give you ability to operate over each primitive. Do a transform and, for example, do a scale of 0, 0, 0. Now, as you could see, we have nothing, but points are there. And if you goes to your main object, as you could see that we shrinked our primitive in the center of itself. Next, I will go ahead and create an add node that will give me a points. Now you could see those points, I think, even such. It's not a proper still because we need a fuse node to fuse all these 4 points, because when we scale the primitive, it has 4 points and all these 4 points going into one place. And if we use a split, now as you could see that 51 thousandths, and now we have 0. 0 is bad. I need to delete geometry but keep points, I think. Yeah, when you add points you need to delete geometry, it keeps only points, because before that we have polygons and primitives, and after that you have only points left. So now without the vex you successfully created the center point of your polygons. And again, we need something for pscale, and let's use this, for example, pcfind. Why not? Control copy and Control V, and sure enough that will give you a proper and cool representation of your radius of your points without any intersection, and that's packed. Maybe you have some weird stuff on the edges, maybe not. And this time let's do a poly extrude. Boom, boom, boom. Let's do a little bit of that, a little more, and it's cool. So you have something like that. And if you do a merge node, and create these two, you have it. Nicely packed geometry based on your primitives with the proper pscale. It's not a perfect, it's not utilized all the sizes of this as we did before, but overall, yeah, it's great. So let's go ahead and do a 3D object with different scenario. Let's move on, and again I will not give you the pixel perfect solution, but we will try and do a little bit better, just better representation of the packed object. Let's copy that, and yeah, now what we want to do, we basically want to do the same as we did here, but here it was a flat surface, but now as you could see some quads are stretched. And you have not just 2 but 4 sides, and basically the logic is the same. You need to find all these sides, do the minimum of that, and just place your copy 2 points. I will not do this guy, but again, for each primitive, not need this, and starting with this guy. Okay. Let's do the first a single path and just focus on this one. We couldn't just do a get bbox in this case, because bbox is the like shrinked cube around, or not a cube but shrinked rectangular object around your object, and that is oriented like the perfect. And in this case, if we take a closer look, I would assume that this guy would be something like that, this bbox thing. And that is not going to work in our case, because we'll have different numbers for that. And we need just a perfect line for this guy, for this, and so on. In order to do that, we need to find the position of each point, and so you need to have a float distance between those 2 points. So first things, we need a position, and the second one, we need a distance. So let's do that. It's a bit, seems like a bit harder or more complex, but to be honest, it's not that scary. Let's do a bigger one. Control plus is giving you the option to have a bigger text. So first let's find the position for all of the points, right? And that will be a vector, pos, and very repetitive task. Pos 0 is point of position, and we need point number of 0. So imagine we have points and numbers, and as you could see, we just have found the position of the first point. We need to do the same 4 times. That will give us 4 position for the 4 points. Apply, and yeah, it's working without any errors. Now we need 4 float distance. So distance 1 or 0 in this case will be a distance between 2 vectors, right? It gives you vector 1 and vector 2. In this case, we need 0 and 1. So let's go and pose 0 and pose 1. So apply, that will give us 4 floats between these 2 distances, and all we have to do is like find the minimal of this. So float again, and basically, yeah, this is it. You want to apply accept. Let me see. You have different sizes, and in this case you need like a center point of that. So obviously you would like to divide that by 2 already, because you know that this will be our pscale. And we'll face another problem in a bit, and I'll show you. But let's go ahead and create our points. Considering we are iterating on the primitive level, we could just write a position of the primitive. That will give you a point in the center of this primitive. And then probably we would need, for this point specific, we would need a group. So you need a name for your group, you need PT number. I want only the group for these points, and set 0 is nothing and 1 is something at least. And if you copy there here, you could go and change it to the target, and we have only 1. But again, we don't have any pscale, but we successfully copied only 1 object to this group. The next thing, obviously, for the orientation purpose, we need a normal. For that we could use vector norm is equal to point function and we need normal for all of the points. So that is why we need to give it beforehand, I think. And let's do a points. So now we read this normal, and again set point attrib. Oh, you know what? We don't need a point level when we go ahead and create a normal. We want to create this normal on the primitive level. That will flatten all the primitive. Otherwise, that will average the point direction, and that could be on the curved surface like that. That could be different. So we want just the center of this primitive and only one direction. the same as the primitive. That is why we need a primitive normal, and then when we read that, it's not on the point but on the primitive level, and we need to change that as a prim num. Okay, and when we do a setPoint attribute, now we could use this as a normal. Do we have any arrows? No. But now, as you could see, it's a proper oriented, and we'll see that better a little bit later when we finally do a setPoint attribute again. So now, as you could see, we have successfully created one pscale, and that should be oriented properly, and so on and so forth. And if we go ahead and check the block end and turn off this single block, as you could see, all our primitives are filled with these tubes. Yeah, beautiful. But we have a problem a bit, like in this area, where we could see that obviously this, I don't need this poly extruded by the way, this min size is something like that, but we have a circle bigger than that. And the problem caused by the order of the points in the polygon. So if that is matched, it's perfectly aligned. But if it's not, we do something like cross numbers. Remember, when we seek for this point position and calculate the distance, we just did it in order, in the circular order. So let's fix that. Let's do a sort. And in this case, I guess we could use a vertex order. And as you could see, bumped, and everything is aligned perfectly. Let's go back and do a poly extrude. And now, as you could see, everything is perfect. And if we compare that to the previous version, you could choose whatever is better for you. For example, in this area, if we took here, you could see this is like more fitted in the square object. Okay, let's go ahead and do with the triangles the same and see what we got. Okay, let's move on. And I took another object with the triangles. It's a front part of the car, a very recognizable car, I would say. And in this case, probably I want to do the same without any calculation. We'll change that in a bit. I want to reuse these circles, and I managed to have a pretty nice result, I would say, but it's not perfect. And if you have the solution, just let me know. I will show you what I mean in a moment. And yeah, in this case we have a perfect triangles. I mean, not perfect, but I know that all of that is triangles. We have normals the same, we sorted it, and we couldn't do that like we did before, because it will give us not a proper thing for that. If we change this part, okay, and maybe just delete. As you could see, we need to calculate the pscale fitted inside the triangle. And luckily for us, of course, in math, there is a formula for that, and it's not that hard to do, to be honest. We don't need to do anything of that besides the add point and all of that stuff. So let's delete this part, let's turn that off. And in order to calculate the proper pscale inside of a triangle, we need two measure nodes for our case. And the first one, considering we are working on the primitive, we need an area. So an area of a triangle, of each triangle, and we need a perimeter. And we change that length of perimeter and change that to per, I would say, to see the lights. Yeah, that is better. So we have all these points and we have a center point. And what I've told you that it's not the center of the triangle in this case. It's rather maybe a B box. I need super precise center of this triangle. In order to do that, I would go and calculate the degree of the angles and do perfect vector going from this corner to this side, divided degree in half, and the intersection of these two, for example, vectors will give me the point something like here. And yeah, let's first go back and do our math for the proper pscale, and that will be, the formula would be the something like that: float scale is equal to area of our triangle divided by half of the perimeter. I think something like that. So let's go ahead and do an area on the primitive, and let's do our P, and that should be our perimeter divided by 2. Yeah, something like that, and indeed it works. Let me go back, and if we do a merge node, I could see that, yeah, indeed it's packed pretty nicely. All the circles have some penetration, intersection. You could solve that, or you could leave that as it is, because from side it's not going to be that visible. For example, from here it's like a treasure front car, but yeah. And if we go back to this, for example, this one example, and that will fit perfectly, because something like here, that will fit perfectly. But we need to calculate the proper center of a triangle, and that is I'm not going to do here, and I will leave that for you. Or I'm not going to calculate, because all that math, maybe you know some very simple method. If do so, please let me know in the comment below, and I will update this method, because we have proper one, but we don't have a proper position for these triangles. Yeah, otherwise it's cool. It could be some diamonds or something like that. Okay, and if you have a sphere, you would obviously need to increase your radius or uniform scale to 2, and that will give you the same cool and useful object or area spot. And we want to solve this problem, right? And what is cool, that you could use another vex, ta-da, like a magic, right? And we could do it only with one function, which is cool, I think. First, I think we need to calculate a normal again and again and again, because we'll move our points in direction of the normal. And one thing, side thought, that you could use an SDF. You could build an SDF, calculate volume sample, calculate volume gradient, and move your points and the amount of the volume sample in the direction of your volume gradient. And basically we would do the same, but with just the points. We'll use this function called wink, and we will go ahead and see what it gives us. Computes a number of mesh around the point, and we need like geometry and vector of origin. Let's do that. And this float number will be, once again, if we check that here, it says if it's inside outside test, the windy number is equal to 1 inside of the mesh. Okay, so that means that if we do a comparison of this number, if we do a comparison of wind, and if that is more or equal to 1, that is a moment when we could use our moving points. So let's do that. Plus equal to normal multiplied by very small number. So that means that we will move our points, but not plus, but minus, in the direction of the normal, and we calculated it before. And yeah, as you could see that we solved it most of the time. And if you want a stronger effect, you could use for each loop with feedback. I think this one, that will give you iteration. So, and if we do only one iteration, obviously that will do only once over all the points. And if we do second one, we could do the same operation over and over again, just to be sure that we have no intersection over. As you could see, it's jumped a bit. And another thing that you could smooth operator. And let's do a third one. I mean, I have a lot of points and a lot of different small, and I need to operate over there. But yeah, let's do 6 of that, and obviously that will give me a better result. Yeah, that's it for now. Obviously, you have a lot of tutorials over there in the internet. I will link a few in the description below, from Entagma, from Copy 2 Points, from Houdini itself, from the Heaven, or I'm not sure where I could find that else. But it gives you an idea, and it's like a fun little exercise of how you could manipulate the points and pscale and the radius. And obviously here you could create a quaternion and rotate it randomly on the one axis or on the others. You could calculate the pscale and move it up on the surface in the direction of this surface. And yeah, everything we told about. But that's it. Oh, one more thing that you could pack nicely with uvsample. Yeah, and you could do that, and I will link again in one tutorial or two for the uvsample. And that means you need a UV projection for your object. You need to work on the one-to-one surface and then project that back. Yeah, that's cool as well. So don't restrict yourself in the one method. Don't be the smartest guy, just be the guy. Matrix is all over the place. Yeah, follow the rabbit, and blue bye and bye bye.